Welcome to Simplified Maths class. Thank you for subscribing to my videos. God bless you. This evening, we'll be taking set theory. Now, in set theory, we have a lot of concepts we are going to be learning in set theory. We will begin with the basic introductory aspect of set theory. From there, we'll go into basic set operations like union of sets, intersection of sets, difference of sets, symmetric difference of sets, and complements of sets. Then we'll come back for set 2, that's the second aspect of set, where we'll be having some other concepts to take, like the set builders notation, the Venn diagrams, and so on. But today, set theory part 1 will be the introductory part, the union, the intersection, the complement, the difference, the symmetric difference, and so on. Now, what is a set? A set is a collection of well-defined objects. Well-defined in the sense that every element or member of a set must have a striking characteristic feature that enables one looking at that particular set to know that these elements are interrelated. That one looking at these elements will know that it's actually obvious that the members of that set have something in common. So that's why we say well-defined objects. Now, take for instance, if you have A as the set of elements and you have in the set a cat, dog, goat, all right? Now you can reasonably conclude that A is a set of domestic animals. Domestic animals. You will conclude that. Now, if you have another set, say B is the set of elements and you have 2, 4, 6, 8, 10, 12, and so on to infinity. When looking at these elements, you will reasonably conclude that B is a set of even numbers. A set of all even numbers, because it continues to infinity, a set of even numbers. But if you have this, let's say Y is the set of elements, and what you have in Y is, for instance, maybe a lion, a tiger, an elephant. Now you can say Y is a set of wild animals. And then if you have, let's say, C is a set of elements and you have A, E, O, U, you can now say that C is a set of vowels. Now observe all the examples I've given. You will notice that in every set of elements, the elements itself that are grouped in the set must have a striking feature that ordinarily when you look at the set, you'll be able to know that yes, they are interrelated. Now, understand something here. If you look at all the examples I've also given, you realize that where I say A is a set, B is a set, Y is a set, C is a set, every set is usually denoted with a capital letter. That's why I use capital letters to denote the sets. However, the members of the set or the elements of the set, the members or elements of the set are usually denoted with small letters, separated by commas and enclosed in braces. You see them denoted by small letters, and they are all separated with commas and then enclosed in this special bracket. We call it braces. Braces. So enclosed in braces. Now, there are what we call the types of sets. We have type sets, we have the singleton set, we have the null set, we have the subset, proper subset, universal set, and so on. But as you progress, you begin to understand them one by one. But before going to the basic set operation, union and intersection of sets, I want you to understand that one of the two types of sets, or one of the various types of sets I want you to know, is the first type we call the null set. Null or empty set is one of the types of set I want you to take note, particularly. The null or the empty set has to do with a set that contains no element in it. Any set that contains no element in it is a null set or an empty set. As you say A equal, you open your braces and you leave it empty, it means A is an empty set or a null set. Either say A is empty this way or you do this. So this also denotes an empty set. So you can use this to denote an empty set. Now the second type of set I want you to note is the singleton set. A singleton set is a set that contains exactly one element in it. A singleton set is a set that contains exactly one element in it. I'll give you an instance. Singleton set. Assuming you have the set of elements A and just what you have in there is cat, it therefore means that A is a singleton set. It has one element and the element is cat. Take note that I did not separate the cat, C-A-T. Alright, I didn't separate them with commas. That's because it's just one object, cat. Now, if you say B is the set of elements and you have 0 in it, therefore B is a singleton set because it has one element, 0 in it. Take notes. Alright, so let's go straight to what we call the basic set operations. The basic set operations. The very first basic set operation I want us to handle is 1, the union of sets. The union of sets. Now, the union of two sets, A and B, is another set, A union B, that contains all the elements that are present in both sets A and B. All the elements found in both sets A and B. Now, assuming you're given a set A to be this, 2, 3, 5, and 7, and then you have another set B, 1, 2, 3, 4, and 6. Now, therefore, A union B. Take note, this U denotes union. A union B. It means we want to gather all the elements that are found in both sets A and B in an increasing order of magnitude, but ensure that repetition is not allowed. So the least element we have here is 1. After 1 we have 2, 2, but we'll take it as only 1, 2. Then after that we have 3. After 3 in an increasing order we have 4. After 4 we have 5. After 5 we have 6. And after 6 we have what? 7. Any other element? No other element. So we stop there. So A union B is 1, 2, 3, 4, 5, 6, 7. It means the union of the two sets A and B is the set A union B that contains all the elements found in both sets A and B, arranged in an order of increasing magnitude, but where repetition is not allowed. That's what union is all about. Now, let's take another example. Assuming you have P to be the set of elements 0, 2, and 4, 6. You have Q, the set of elements 1, 3, 7, 8, 9. And then R to be the set of elements 1, 2, 3, 6. Therefore, P union Q union R, which is a union of all the three sets P, Q, and R. So we begin the union of the three sets. We start from the least element 0, comma, we have 1, no repetition. Any other one we have 2, no repetition. After 2 we have 3. After 3 we have 4. After 4 there's no 5, so we have 6. After 6 we have 7. After 7 we have 8. After 8 we have 9. So that gives us the union of the three sets P, Q, and R. So that's what we call the union of sets. And the U there denotes union. So we go straight to intersection of sets. Intersection of sets. Intersection of sets. Now, the intersection of two sets A and B is another set A intersection B, which contains only those elements that are common in both sets A and B. Say, for instance, you have a set A giving us 2, 3, 5, and 8. Then you have another set B giving us 1, 2, 3, 7, and 9. Therefore, A intersection B, the small n here denotes intersection. It means here we're only asked to look for the elements that are common between A and B, the intersecting elements. If you look at it, you see 2 is common, we take 2. Then we have 3 is common, we take 3. Any other element? No other element common. So it means that the intersection of the sets A and B is 2 and 3, because those are the only elements intersecting between sets A and B. That's intersection. Now, we can also try intersection with this other example here. So we have P, Q, and R, and we are asked to find the intersection of the three sets. So we want to find the intersection of P, P intersection Q, and intersection R. P intersection Q intersection R. So what is going to be the outcome of the intersection of these three sets? So let's look at the three sets and see if there are any intersecting elements. 0, no 0 here, 1, 1, no 1 here, 2, no 2 here, 3, 4, no, 6. So there is no particular element that you can see in P, at the same time see in Q, and at the same time see in R. There is no particular element that is intersecting between the three sets. It therefore means that P intersection Q intersection R is empty. So this is what we call an empty set, because we don't have a single element that is common between P, Q, and R. So that is intersection of two sets. We'll go straight to what we call the difference of sets. Difference of sets. I. Difference of sets. Now, the difference of two sets A and B is another set A minus B, which contains all the elements you see in A, but you can't see it in B. All the elements present in set A, but not present in set B. Say, for instance, what if you have A to be the set of elements 2, 3, 4, 5, and 7. And then you have B to be the set of elements 1, 2, 4, 7, and 8. Now, we can look for both A difference B and B difference A. A difference B, that's A minus B, this denotes difference. A difference B will be all the elements you can clearly see in A, but you can't see the elements in B. Okay? All the elements I can see in A, but I can't see in B. 2 is here, and I can see it here. 3 is in A, but I can't see it in B. 4 is here, 5 is here. I can see 5 here in A, but I can't see 5 in B. And then 7, 7. So that's all. So 3 and 5. It therefore means that 3 and 5 are the elements you see in A, but you can't see them in B. That's A difference B. And then B difference A. B difference A means all the elements you can see in B, but you can't see them in A. All the element present in set B, but not in set A. All right, I can see 1 in B, but not in A, so I take 1. 2 is here, 4 is here, 7 is there. I can see 8 in B, but I cannot see 8 in A, so I take the 8. It therefore means that B difference A is 1 and 8. Please take note, A difference B can be written as A slash B. So whenever you see A slash B, it means it is A difference B. And then B difference A can also be written as B slash A. It means B difference A. Now, so far, we have been able to get A difference B, and we have been able to deduce B difference A. That leads us now to the next concept I want you to know, the final one, number 4, which is symmetric difference of sets. symmetric difference of sets. Now, the symmetric difference of two sets A and B has to be with all the elements you see in set A, but you cannot see them in set B. And at the same time, all the elements you see in set B and you cannot see them in set A. That's what symmetric difference is. Which means that if you were given A as this, and you are also giving B as this, for you to get symmetric difference, the first thing you need to do is to get A difference B, which has given you this. And after that, you now find B difference A, which has given you this. Therefore, A symmetric difference B now will be the union of the two answers. So where you have A difference B, you had 3 and 5. Where you had B difference A, you had 1 and 8. So the symmetric difference of A and B means you join the two solutions. So that will be 1, 3, 5, and then 8. So that's what we call symmetric difference. So you have to understand that the A symmetric difference B is the same thing as A difference B union B difference A. It means whatever you have as A difference B, 3 and 5, and whatever you have as B difference A, 1 and 8, when you join the two together, when you find the union of those two differences, the result is what we call the symmetric difference. So this is symmetric difference. That triangle symbol is for symmetric difference, while this is difference. So we have really learned some basic concepts. I want you to have them at the back of your mind. When next we'll be meeting in set theory part 2, we'll be handling problems that involved complements of a set, power set, and how to solve basic problems that involves everything from union, intersection, difference, symmetric difference, power set, and complement, all encompassed in one problem. That will be our set theory part 2. And then the set theory part 3, we are going to just anchor it only on set builders notation, and set theory part 4 will be everything that has to do with Venn diagrams. And so please, I will advise you to please like the video and then click on subscribe, so that as these videos pop up, you can be able to meet them at the point of them being released, so that you don't miss any of our videos for any reason. They are all very important, as they will make you the professional mathematics you ought to be. God bless you, and thank you for subscribing to all our previous videos. See you in set theory part 2. Cheers.